Welcome back, guys, to another NeetCode slash LeetCode grind video. We're back at it. Yesterday, we were a bit, let's just say, involved with other activities, so we're not able to put out, that long of a video. But right now, we're back with another 1 hour, hopefully more than 1 hour. We'll try to keep 1 hour 8 minutes. Again, doing LeetCode. Yesterday, we're not able to do a new question, even though we were able to do the reorder linked list one. The optimal way with O of one space complexity had like three subparts to it. And I think today's video's aim would be to do a bit of linked list or maybe binary search. You never know. You never know what I like. So I have this. I have brown noise because you already know. Yeah, the one thing we are learning about is reorder list, and it's funny because this solution, the way he solves it, it's the way it's very fun. Is let's say, okay, I have this. Let's take a very simple example. Let's go to Scali draw. So the logic behind solving this is quite simple once he explains it, right? So this is our linked list, right? What we do is we find the middlemost point. So this is the middlemost point roughly. We break it over here. So this is our linked list at the moment. So we have 2, we have 4, we have 6, and we have 8, and this is none. What we do over here is we come up to the middlemost value, we split the list. So now we have two lists now from the one linked list that we got. We have 2 and 4, and this is none. And then we have this list, which is 6, 8, and none, right? So the first step would be to find the middlemost value, right? Second step would be to split it, and our third step would be to take the second half and actually reverse it, right? So we do 8, 6, none, and this though will be same, right? If I just take this will be same over here, right? Now our step would be to have one pointer over here and have one pointer over here and start merging them, right? And the way we merge them is 2, then 8, then 4, and then 6, right? 2, 8, 4, 6, and this is none, and that will be easy. That's the way we solve it. Right, and the way we reverse it is because we want to do 2, we want to do 8, and then we want to do 4, and we want to do 6, right? We'll do 4, 6, but we have to come over here. So instead, we just reverse it directly. So the very first thing would be find the middlemost node of the linked list, right? That will be our first step. And the way we do this, right? The way we do this is, let's say, take a simple list. We'll have two pointers. We'll have a slow and we will have fast. Now fast will keep moving until it is pointing to none or the next element is none. So over here, let's say, very simple example, if I had this as n, well, the next element is none, right? And so that will be issue, right? But if the next element is not none, and this is like none, if this is like none, if like like it'll be like 1 2 like type shit. So like now this is like this, so this will move 1 and this will move twice. So now fast will be over here and slow will be over here. So wherever slow will be pointing, that will be our middlemost node, right? And so the way we do this is very simple. We do slow is equal to head, we do fast is also equal to head at the moment. So we can do something like this. We can say slow is equal to fast is equal to head. Now while fast and fast dot next, right? What this means is while fast is not none and fast dot next is not none, and this very nicely takes care of the edge cases where if, let's say, head is none, well, this will not run. Or what if head ka next none hai, this will also not run. So that takes care of us. Our slow is incremented by slow dot next, while our fast is incremented two times. So fast dot next ka next, right? Right. Now, after this is ran, our slow will be pointing to the middlemost value. So let's say if this is like odd number, so we'll just say, okay, we'll consider this as our second half and this our first half, doesn't really matter, right? And so what we will do is we will pretty much say that this will be our, so we'll just take this example, right? This will be our second list. We want to cut this chain exactly. So we want to say second is equal to slow dot next. Now I want to do slow dot next is equal to none because now I am cutting this thing off, right? And so now this is what the situation is, right? Um, this connecting the linked list right? So now next second is equal to slow dot next, while slow dot next is none. Right now our second step is reverse the second half of the linked list, and now we know how to reverse second half of a linked list. We can say previous is equal to none, right? And so the way we do this is our start point pretty much. And so we want to do current is equal to second. Now while current, right, while it is not none, what I want to do is I want to do something like temp is equal to current dot next, right, while current, right, so current dot next is equal to previous, and previous is equal to current dot next, and our current is equal to temp. So how will this work? Now over here we have, let's take this example, 6, 8 and none. Now our previous is none, current is second, right, this is second, and while current, so now while current is not none, we'll say that this will be our temp, right? We'll say current dot next is previous, this is none हो गया, ये chain टूट गया यहाँ पे, right? Then we say previous, right? Then we say previous, now this is our previous, right? And then we do current is equal to temp. So now current comes over here. Now again current is over here, so temp is next, so the temp contains null, right? Now next will be previous, so now it will be pointing over here, and our previous will be 8, and then it will go current dot temp. Now current is null, so it will stop. So now we know that the previous will contain the point that we want to start from, so we can say second is equal to previous, right? Because second now contains the second contains initially the list, contains to know that where we want to start our linked list, our second linked list from. So this is essentially the third step. And now the actual fourth step is merging the two linked lists uh, together, so to speak, right? And this is the part where I was a bit confused, and like I do know the solution for that. That this is my solution, the one I came up with. Let me just open this side. Right, the solution that NeetCode does something like this, right? He says, okay, let's, yeah, I mean, this makes sense, right? So I mean, the first will be our head, and our second, well, second to मैं पहले से बना चुका हूँ, so yeah, we could pretty much have them in one sense. You can say first is equal to head, second is equal to tail. That could be said. So we have something like this. So now we have in this step. So how do we do this? This is our first, this is our second. Let's assume for the case that both have like equal length, right? So let's try to solve this by myself. Let's see if I could do this. So both are equal length, so I don't have to worry about which one is null. So I could have anything as null. I can say while first, right? And we don't want to return anything. It's like none, right? So while first, right? So now what I want to do is I want to connect this with this, but I want to have that. So I will do temp one is equal to first dot next, right? And I also want to have this because I want to change the loop there, so I'll do temp 2 is equal to second dot next as well, right? Cool. And now I'll pretty much merge this with this, right? So I'll say something like first, so this is just that, then I'll do first dot next is equal to second, right? Right, so now this goes over here, and this will actually just do on the temp one, and then I'll do second dot next is equal to temp one, right, so to speak. And that's pretty much it. That's what we want to do as of now. So this will run up, and this will run up, and now we will just update our first to point to tmp1. So now our first comes over here, and then we'll do second is equal to tmp2, right? So now our second comes over here, right? And now we again do this as null tmp1, and this has this tmp2. Then we say first dot next is equal to second, so now it goes over here. So 2 4 8 2 8 4, and then we go there, and then second comes to temp, so 6 points to null, right? And then we do first is equal to temp, and so now this will stop, right? And so if I run this, for some case this might pass, line 37 is the issue. Yeah, that's the issue apparently. Why is this the issue? And especially on this case, it's the issue. That is weird. Right, so let me just figure out why that's the issue. 2 4 none. I mean none कर रहा हूँ ना उसको इधर. I am doing this none, right? Slow second is equal to slow dot next is none. Yes, we do that, and we essentially reverse this starting off. So यहाँ पे भी इशू है. ठीक है, कोई बात नहीं. Let me figure this out. 6 8 है ना, तो अभी 8 6 none none हो रहा है ना, none हो रहा है. Current second. While current temp is equal to current dot next, yes. Current dot next is equal to previous, yes. Previous is equal to current dot. ना ये गलती है ना. Current it's equal to current. My bad. It's equal to current. That's the issue that we had. Yeah, that was one of the issues. So current dot next is equal to previous, right? So current dot next is current dot next is equal to previous, and then previous becomes equal to current, and then current becomes equal to temp. Okay, that is fine. Then we have first is equal to head, and second is equal to previous. Now while first we would do tmp1 first dot next, tmp2 second dot next. This is how we do that, right? Starting off ही उसे करते हैं. Crazy. Slow is equal to head and fast is equal to head dot next. ऐसे ही करते हैं. वाओ. If I magically change this to second and if this works right, I'll be very sad. Okay, I'm sad now. um first of all मेरा ये गलत हो गया था. Okay, let it be. um why though, right? Why is this not going to work in first, right? While first, right? Why does this one work, right? Because the way the loop works, it's okay. Now it's the issue. Okay, it works on case one. It works on case one. It fails in this case. Why though? Now here's the fun part, right? Why does it fail? Now if you look over here, the middlemost value will be this, right? Clearly. So our first half will be this, and our second half will be this, right? So what we'll have is 2 4 6 none, and we'll have 10 after reversing it obviously, and none. And so what will happen is we'll be talking about like this, right? We'll be doing all the changes. That means we'll be somewhat like ding ding ding, इसको यहाँ लेके गए, डिंग डिंग डिंग, इसको फिर यहाँ रूट किए, देन डिंग 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 यहाँ पे आए हम लोग, देन डिंग 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 हम लोग यहाँ पे आए, ग्रेट. इसको हम लोग यहाँ पे रूट किए, इसको हम लोग हटाए, हम लोग इसको यहाँ पे गए, ठीक है. देन डिंग 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 हम लोग यहाँ पे आए, एंड डिंग 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 ये नन पे आ गया. सो हाउ डू वी प्रिवेंट दैट फ्रॉम हैपनिंग? And you can clearly see कि it is by effect कि either first and second will be equal, right? It means key the length, if we were to do length first, will be equal to length of second, or what will happen, these are the only two situations, or this will be less than. So it is pretty much somewhat like this, something like this, right? This will what will happen, right? Our length of first will be either greater than or equal to the length of second. So having this as first wouldn't make sense because we want to cover second first, and second will always be less. So we will be something like second. This question really just bullied me, to be honest with you. I don't know what to say about this question. Like, I feel like I want to just do merge two sorted list question now. Just to this question is very simple. I overcomplicated. I'll actually just remove this because it's way too overcomplicated. Right. Okay. Let's just clear the canvas. Um, um, I think I should solve this merging question first. I think this is a bad example, but chalo, theek hai, we'll start. And so we have two linked lists, right? And they're both sorted with their own respect. And we want to merge both of them. We want to merge both of them so they form this, right? And so we get list one and list two. Okay, so I mean, it's an interesting question. Let's see how would I solve this. So we have one, we have two. Okay. Okay. So I think the most common way is I'll have one pointer and the head list one, and another pointer list two as the providers. And now I'll compare both of them. So both of them are equal. So that means I can choose either one of them. So I'll choose, I choose this as my starting. I think the one thing that we can do is sorted head is equal to none at the moment, right? And this is what gets returned, to be honest. Like this is what is returned sorted head, right? So this will make sense. Let me make the font a bit shorter, so to speak. Right, that's much better. Okay, well, that's still this a bit clumsy at best. Yeah, I think that's good. Aye. Okay, chat. Okay, this last thing. This last thing. This is do that. Okay, good. Chill. So we gonna make our sorted head just point to this, right? And then we just push this up ahead at L2, right? So this is gone, and now we remove this, and now this points to L2. And now we compare with L1 L2. Well, L is greater, so we just push this back to over here, and we now push L2 over here. We compare them. Well, L2 is shorter, then we just go over here and we push this forward, right? So this goes away, and we compare that, and so we say, okay, well, 3 is shorter, then L2, and we say, well, that's then 0 4, and we can then push this to none. the moment one list becomes none, we can just append the rest of them together because the very fact is अगर ये पूरा complete हो गया है मतलब इसका ये मतलब है कि इनसे सब बड़े element ही बचे हैं, right? So how can we do this? I think the one thing I can do is while list1 and list2, right? That makes sense. Right. Let's just keep this simple. Let's just assume they're both of the same size. And so we will just say if list one, okay, I'm using C pointer approach. So there are many cases of what will happen. So the values, the first thing is if list one ka val is equal to list two ka val, we will do something, right? Elif list one dot val is greater than list two ka val, we will do something, and else in this case is list one ka val um, list one ka val. Why I'm not able to type today? Right, this is one of those cases that could happen. Right. Actually, I don't want to do that. I'll do something like list one and L2 is list two. I don't want to really change the pointers they're pointing to because that would be kind of weird. Right. Mm. Also, shorter variable name is much better than longer variable name, in my opinion. um, I'll change it over here as well. Okay. So yeah, okay. So we have while L1 and L2 still are there, right? We would do so now if L1 and L2 are equal, so to speak, right? What we want to do? Well, it doesn't matter which one we take, right? It doesn't really matter. What we can say is we can say, well, sorted head is equal to L1, which is pointed L1, right? And right, so now we will do sorted. So we say, well, sorted head is now equal to L1, right? It points to L1, and then at the moment this will point to none, right? But we will store the next value of this somewhere. I mean, we could do something like L1 is equal to L1 dot next, right? Move this, um, right? But right, and L2 won't move. L2 will just stay there wherever it is. It will just stay there. I think that's what we did. Let's not move that. Uh, okay. Erasing this is a pain in the ass, to be honest, chat. Let's actually move this. Okay. Okay. This is okay. So we do sorted head, and this we have L2. So now, क्योंकि दोनों का value same है, we just say well sorted head will be pointing to ये L1 वाला, so 1, right? We pretty much point. This essentially is pointing somewhere over here, and we say कि L1 is equal to L1 dot next, so L1 is over here, and then we do um, sorted head dot next is equal to none. Chad, I might be looking at the solution because I mean, how can I solve this? What's in this? You guys see, you can see my thumbnail and all that. It's crazy. Um, just give me 2 minutes, guys. If you're back, okay. Sorted head is equal to L1. Like this makes sense. Like the first one will be the start of the list. It makes sense to just have this in every iteration, so to speak. For like this will just change, right? This will actually be L1, right? This will be L2. Okay. Um, right. L2, and the first time we'll be going. Right, so this we essentially just plug it and put it. So this one pointing over there, and we'll also say next. L next will be L1 dot next, right? So we have this L1 dot next, so to speak. But we don't know whether that will be in that loop. So we'll do L1 dot next is equal to none, right? And it will do tail is equal to L1, essentially. So L next is essentially L1 dot next, and we do L1 dot next is equal to none, and we'll say tail is equal to L1. L1 dot next, L next is equal to L1 dot next, and right? And I guess, and tail is not, well, the first tail was on the L1, so to speak, and tail is not, tail equal to L1 over here, um, right? Tail is equal to, this is complicated code, but I know this might work. L next will be L1 dot next, and then um, right, we say L next is equal to 1, L1 dot next. I'm so confused. I just watched the video. I'm actually so confused. Like, if I go ahead, I'll be even more confused than I am right now. So, just watch the video and try to figure out the patterns, to be honest with you.
Hey guys, it's me again, and let's solve another LeetCode problem,
And
merge two sorted lists. So this is an easy problem. It's a mainly fundamental problem. There's nothing crazy about it, but it's a pretty good problem to understand some basic stuff. So we're given two linked lists, right? So this is the first one, this is the second one. Both of them are already sorted, and we just want to merge them into an output linked list. The only catch is that we have to use the original nodes, right? Like we can't create copies of the nodes. So let's say we have self. So your intuition will probably solve this problem for you. So it's basically, since the lists are sorted, we start at the beginning for both of them, right? Now we can just
just give me 2 minutes, guys. Yep.
compare the values. So they're both 1, so it doesn't really matter which one we pick. So we can just take, I'll say list 1, right? So we'll take this one and insert it in our output and then move to the next one and then just continue the algorithm. The only catch here is that right now our output list is empty, right? So this kind of gives us an edge case because we don't even have a list itself yet. So what I like to do is just create like a dummy node. So this is a pretty common technique, and you avoid any edge cases. You avoid the edge case of the initial empty list. So let's say we start out with a list, right? This is a dummy node. It can have any possible value. So now we're going to insert 1 into our list. Now we're going to compare two values of 2 and 1. In this case, the value from list 2 is smaller, so we're going to take it, insert it into our output list, 1. Now we're going to be comparing these two, so 2 and 3. The value from list 1 is smaller, we take it and insert it into our output, 2. And then of course we can move to the last value in list 1. So now we're at 4 and 3. Which one of them is smaller? Of course 3, which is the value in list 2. I'm running out of space, but I think you get the idea at this point. This is the last edge case that we have to worry about. So now for list 1, there aren't any more values left, right? So we can't really continue our algorithm. Lucky for us, there's only one value left in list 2. Do in this case, always going to be the case, right? Maybe there could be values in list 2. Now, what would we do in this case? Well, we can do a really easy thing, which is just take the remaining portion is empty. Of course, the list 2 in the remaining portion of the list. So if we run out, so if one of the lists is empty, of course the list 2 in this case is still sorted, so we can literally just take that list, insert it into the end of our result, right? So that's basically the idea. Okay, now let's write the code. So remember, I like, and most people like to use this technique of creating a dummy node, so you don't have to worry about the edge case of inserting into an empty list. The tail of our list is initially, I'm just going to say, the dummy. So now we're going to keep going. We're going to iterate through these two lists. What's the condition that we're going to do that? Basically, if both of them are non-empty, right? Because that's when we can actually compare the two values. So while list 1 and list 2 are non-null. So now we can do our comparison. So if the value of list 1 is less than the value of list 2, then of course we're going to take the list 1 value and insert it into our tail. So tail.next is going to be the node itself, right? List 1 node. And then we can, of course, update our list 1 pointer. Now, the else case is if list 2 is less than or equal, right? So if they were equal, the else condition would evaluate. So we're going to do the exact same thing, except list 2 is going to be inserted. Tail pointer is going to be updated regardless. Return dummy.next, return the list, but don't forget our condition was the other one isn't right now. Well, the end next. So if L1 is non-null, then we'll say tail.next is equal to L1. So we're just taking that remaining portion of L1 and inserting it into the end of null. So let me just run it to prove, and some random percentages that always seem to change. Right now it's 65%, but I'm sure if I submit it again, it could be 10%, it could be 99%.
So this is less, right? So what we can do is we can do tail dot next is equal to L2 and L2 dot L2 next. L2 is equal to L2 dot next, and essentially we'll do tail is equal to tail dot next because we know at the end of it, um, right? So pretty much इसका क्या मतलब है कि we can have like essentially three cases where both the lists are same. One is bigger than one is bigger, one is shorter, one is the other way around, right? In both of the cases, the one that is limiting will close it. And so if L1, right, if L1 is not none, um, we can say tail dot next is equal to L1, else we can say tail dot next is equal to L2, right? Yeah, because so either if L1 is not none, matlab L1, because by the end of this we'll be incrementing them one by one. So भाई भाई क्योंकि यहाँ पे आ गया and ये none हो गया. So मतलब ये stop हो जाएगा. So if L1 is none, that means if L1 is not none, that means because after this loop runs, we can have either two conditions, either that L1 has reached the end or L2 has reached the end. If both of them have reached, then this will not actually um, right. After this is either both have reached none. This might fail test case. This will fail a test case. Does it? Okay. Um, right. So if it could either be that this or if L2 is it, then we can do tail dot next is equal to L2. It's much better. The thing is that after this is run, it could either be the case that both L1 and L2 is none, or it could be the case that either L1 is none, L2 is not, L2 is none. So what we do is just do that. The hell just happened? Okay, and yeah, exactly that would happen. And to be honest, this I figured out key that one, the one we did over here, reorder list. The reason why we do while second is because we know, as I said again, the length of second, the length of first will always be greater than or equal to length of second. And one more thing we do is length of first minus length of second will either be equal to 0 or will be equal to 1, because as you know this will only be greater than 1. That's why we pretty much say ki we do that. Okay, so we just essentially make a dummy, right, and this points to nothing. Essentially this is pointing to none. This is a node itself and the tail is over here. Cool. Okay. The one question that I had trouble solving yesterday, which I'm kind of embarrassed to say, was I think it was shifting the zeros, something. Move zeros. It's an easy question, but I was just like having let's just say good time, not able to solve it, which was kind of shit. Like I'm not able to solve an easy question, right? But let's try to solve this. I guess I think because that would be like I mean I will have to revise these three things. To be honest, I did kind of know what to do, but I was kind of like thrown aback by like, okay, how do I implement this, right? So I think that's the cap at the moment. Key, how can you put your algorithm, so to speak, in actual words? So this is our output that we want to get. Num's length could be 1 to 10. Um, hmm. Okay, so we want to shift all of the non-zero, like all the zero element to the one place while keeping the relative placements of 1, 3, 12 the same. Makes sense. Okay, so the most naive option would be okay, I run a loop from I essentially, right? And I check if the element is 0. If it is 0, then I will stop over here and I'll check the remaining array to find a non-zero element, the first non-zero element that can replace it. So if I start element of say, okay, if this is non-zero, then I will pretty much swipe this with that. So now I will have 1, 0, 0, 3, 12. Now I'll check the very next element and I will check the remaining array for the next non-zero element. So 3 will come and I'll just swipe this with 3. So we'll have 1, 3, 0, 0, 12. I will check the side to find and then I'll do 1, 3, 12, 0, 0, and I'll check if I can't find it, I'll stop. And if I come at the last element, well, the last element, I mean, if I come to the last element, it won't be able to run, right? So I think that makes sense. How will I implement this in code? I guess good question. So 0, 1, 0, 0, 3, 12. Right, so something like y is equal to 0 while I is less than the length of nums. Now if nums I is equal to 0, let's do something. Um, Else if it's not equal to 0, I don't think that's an issue, right? If it's not equal to 0, then just go ahead I plus 1, right? Like if you think about it, if it's like 1, 0, 2, um, if this is not 0, great, start from here and let's try to find, right? So if it's equal to that, then we'll say j is equal to I plus 1, so to speak, and I'll say while j is less than length of nums, because I don't want to check at the point, right? I want to see if nums j is equal to 0. If it's not equal to 0, we'll just break it. Else we'll just do I j plus 1, right? If nums of j is not equal to 0, then we'll break it because then we would need this, right? So j is not equal to 0, right? So we break this loop. If not, then just continue forward, right? For example, um, right? So yeah, so we just go ahead with this, right? When we break out of the loop, right? We break out of that loop, and so now we could pretty much swipe them, and so I can say nums I is equal to nums j is equal to nums j equal to nums I. So this is pretty much swiping them, and I think at the end we'll just do plus equal 1 over here. So now that we are done essentially swiping it, right, you then check the next element, right? We'll check the next element and just carry on. So list index out of range. So I think, okay, for which I are we looking for? Print I also. Okay, इस I के लिए हम लोग देख रहे हैं. So I mean, if you're looking for this I, then we'll do j plus I over here. So while j is less than nums, um, as you can see, it's almost done with it. So 1 3 12 0 0. Problem यहाँ पे आ रहा है, तब this takes this consideration. Do we really want to check for the last element? Because think about it, we don't want to really check for the last element. We want to do something like this. Like we don't really want to check for the last element, so we won't check for the last element, right? This is 1 2 3 4 5. So 5 minus 1 is equal to 4. So 0 1 2 3. Again, if this is, again, let me just check one more time. सेम चीज़ें फंस रहे हैं हम लोग, यहाँ पे ही फंस रहे हैं. ठीक है, जे ठीक है, बट यहाँ तक विल चेक टिल द लास्ट. ग्रेट है, जे प्लस 1 हो रहा है, एंड देन ये ब्रेक हो पा रहा है बिकॉज एसेंशियली दिस ब्रेक्स. द प्रॉब्लम इज राइट, हम लोग क्या कर रहे हैं, प्रॉब्लम ये है कि okay, I think what the problem is, I can pretty much do this over here. um, right, this is the problem. समझ गया. तो जैसे ही हम लोग को nums j मिलता है, हम लोग वहाँ पे रिप्लेस कर दें, we break out of this loop, right, and then just do that. अगर नहीं मिल रहा हम लोग को, तो ये j ऐसे करता रहेगा, and this will essentially break out the loop out of itself. Let's see if this works or not. So we have I is equal to 0 while I is less than length of nums. We don't want to check for the last element because उसके right side में कुछ रहेगा नहीं, right? And if we say if nums I is equal to 0, we'll do something, but anyhow we are not, I mean at that way हम लोग last में यही कर रहे हैं. So we could just come and then say L, sorry my bad, print nums. Let's go nums is equal to this, कुछ नहीं होता, great, right? So if nums this, so we'll say j I plus 1 while j is less than length of nums itself. हम पूरा list तक check करने वाले हैं, end तक. If nums j is not equal to 0, we will say nums I nums j is equal to nums j nums I break this, right? And if else we don't find it, we'll just do j plus 1, and if it reaches end, then our loop will take care of it for us, right? I don't think I'm missing anything unless there's some edge case that God forbids I have not considered, like some demonic edge case, right? This is you could say it's like a n squared solution, pretty much. Okay, that's bad because so the way this solution works is quite pathetic. It says, okay, well, I mean, to be honest, the reason why I do that is you can have 0 0. The idea with that is, and I know what I'm trying to say is because अगर ये ऐसे है, we could have something like 0 0 1, and we check for all the remaining over here, and इसको हम लोग swipe कर दिए, and 0 या 1 0, I mean think of it like this, ठीक है, 0 0 1 2, this this will be replaced by this, so 1 0 1 0 0 2. Now I have to worry about this 0 over here. But that I know ki this guy was next to this guy. 0 0 1 2, so this will be 1 0 0 2, and then we come over here and do 1 2 0 0. This we're not checking the last element at all. Essentially, even if it goes to the last element, we don't check the last element. Okay. We check only till this element. This is our time is horrendous, as you can see. It's like this, like 3 seconds. So not this fastest operation per se. In the follow-up, we minimize the number of operations done, and 2 pointers. Okay, let's see if we can use 2 pointers over here. First of all, I'm very hungry right now, so when I'm hungry, I don't think that properly. So let's have left pointer and right pointer next to it. Um, Left pointer, right pointer could work. Okay, let's see if this could work. So essentially, we just say something like while left is equal to 0, I is equal to 1, while left is this and r is less. Um, Actually, we don't really care about the last element, to be honest, because we don't have anything to check. R is less than length of nums. क्या कर रहा हूँ भाई मैं? Right? Let's think about this logically. If I do this, crazy. ठीक है. If I were to do this, right. So if we were to do this, we can have one left pointer over here, and this one right pointer over here. Um, if the left, so basically left right pointer, left will look for zeros, right will look for non-zeros. So if over here this is 0, so now the right will scan for a non-zero element, pretty much. If I were to think about it, let's just think about it. Let's keep it very simple. Let's keep it while r is less than length of nums minus 1, ऐसे कुछ करके, but just something like that, because I mean, to be honest, let's keep it something like while r is less than length of nums, like ऐसा कुछ रखते हैं. And so if L is equal, so one thing we'll say is if nums L is equal to 0, then we have to check, right? We have to start checking for any non-zero element, and you can see that हमारा R1, right? So one thing we can say is over here is we say if nums are is equal is nums are is not okay. I think what we can say is if nums are is not equal to 0, we could just nonchalantly just do this, right, which is perfect. मैं क्या कर रहा हूँ अपने साथ r and we can do nums. My typing has decrementally gotten bad. Yeah, so we essentially will swipe them. So after they are swiped, I would essentially just update my pointer so that now that L, it will essentially now come over here. So now my L will come to R and my R, right, and my R will go plus equal 1, so to speak. Right, I don't know how correct this is gonna be. What's the issue over here? Ambiguous value L, हाँ ambiguous ही रहने वाला है. Nums R is equal to 0. So this makes sense, so to speak. At the moment अभी तक तो sense बना रहा है, right? Now while nums R is equal to 0, what we would want to do is we would pretty much then want to get R to the first non-zero value. So now after this change we will have right, actually गलत है. L will be over here, R will be over here, right? राइट सो नाउ प्रिटी मच यहाँ पे क्या होगा अब क्योंकि हम लोग इसको स्वाइप कर चुके हैं. नाउ एल विल पॉइंट ओवर हियर लाइक जहाँ पे आर था एंड नाउ आर विल कम पॉइंट ओवर हियर, राइट, नेक्स्ट वाला. करेक्ट. नाउ अब हम लोग को नाउ राइट दैट हैपेंस. नाउ दिस लूप pretty much runs again. If nums is L, so now R has to find. So now R pretty much has to check ye entire list. So the way I will say this is while nums R is equal to 0, so we need to make sure कि nums R, it should keep moving forward, ensuring it should only keep moving forward if both conditions true. That is if nums R is equal to 0 and R is less than length of nums, right? ये भी एक चीज़ देखना होगा हम लोग को, right? So now it will be saying nums R is equal to 0, so it will keep moving. So we'll do R plus 1. So nums R is equal to 0 and is less than, so ठीक है R. Now nums R नहीं है, that means we have gotten our essentially our this, right? So this is we have gotten our first that because we have gotten the first non-zero element, we can again just come over here and use this expression, right? So now this will swipe it over here. So 1 3 0 0 13. तो सेम ही चीज हो रहा है ना. This is the same thing, bro. सेम ही चीज हो रही है. ये चेक कर रहा है यहाँ, यहाँ चेक कर रहा है यहाँ, तो this will be off and square, right? There's nothing that better. So optimal time complexity of doing moves zeros LeetCode question. Okay, so this is the optimal. I really can't think of any because my brain is just blasting off. I'm sorry for not being able to solve this solution, and even though it's easy, I'm dumb. But yeah, I guess I'll leave. I'm hungry a lot, very hungry right now. I have to go eat. Thank you for tuning in. I'm kind of a bit sad, but so anyways, we'll improve on this. Right. So thank you for joining in for another NeetCode/LeetCode grind session with one and only. See you later, alligator.